Loss functions. Loss functions in machine learning. AI beginner means intermediate level. Introduction. Machine learning models learn by making predictions and improving them over time. When a model makes a prediction, it needs a way to measure how good or how bad the prediction is. This measurement is called a loss function. Loss functions are essential for training machine learning and neural network models because they tell the model how far its prediction is from the correct answer. Loss functions are used in many AI systems such as image classification, speech recognition, recommendation systems, financial prediction, medical diagnosis. Understanding loss functions is important for learning machine learning, deep learning, and model training. What is a loss function? A loss function is a mathematical function that measures the difference between a model's predicted value and the actual value. In simple words, loss function equals a measure of prediction error. Example concept: actual value equals 100. Predicted value equals 80. Loss equals prediction error. The goal of machine learning is to minimize this loss during training. Lower loss means the model is performing better. Why loss functions are important? Loss functions guide the learning process of machine learning models. Without a loss function, a model would not know how wrong its predictions are, how to improve its parameters when the model is performing well. Example concept: prediction means calculate, loss means update model. Loss functions allow algorithms such as gradient descent to update model parameters. Loss function in neural network training. During neural network training, the process works like this: input data, down pointing arrow, model prediction, down pointing arrow, loss function calculates error, down pointing arrow, backpropagation updates weights, down pointing arrow, model improves. This process repeats many times until the loss becomes small. Mathematical representation of loss. Loss functions calculate the difference between actual values and predicted values. For example, loss equals f, y, hat, y, where, y equals actual value, y, caret, equals predicted value, f equals loss function. The goal during training is minimize loss. Types of loss functions. Different machine learning tasks require different loss functions. Common loss functions include mean squared error, MSE, mean absolute error, MAE, binary cross entropy, categorical cross entropy, hinge loss. Each loss function is designed for specific machine learning problems. Mean squared error, MSE. Mean squared error is commonly used for regression problems. It measures the average squared difference between predicted and actual values. MSE equals frac 1 n sum underscore I equals 1 caret n y underscore I hat y underscore I squared. Example: actual price equals 200. Predicted price equals 180. Error equals 20. Squared error equals 400. MSE penalizes larger errors more heavily because of the square. Applications include house price prediction, stock forecasting, demand prediction, mean absolute error, MAE. Mean absolute error calculates the average absolute difference between predictions and actual values. MAE equals frac 1 n sum underscore I equals 1 caret n y underscore I hat y underscore I. Example: actual value equals 100. Predicted value equals 90. Error equals 10. MAE is simpler than MSE and less sensitive to large outliers. Applications include sales forecasting, weather prediction, financial predictions, binary cross entropy. Binary cross entropy is used for binary classification problems. Examples include spam versus non-spam email, fraud versus normal transaction, disease versus healthy. L equals y log p plus 1y log 1p, where y equals actual label, p equals predicted probability. Example concept: actual label equals 1, predicted probability equals 0.8. Loss measures prediction accuracy. Categorical cross-entropy. Categorical cross-entropy is used for multi-class classification problems. Examples include image classification, language detection, object recognition. L equals sum underscore I equals 1, caret, n, y underscore I, log p underscore I. Example: image classification. Cat means 0.7. Dog means 0.2. Rabbit means 0.1. The loss measures how close the predicted probabilities are to the correct class. Hinge loss. Hinge loss is commonly used in support vector machines. SVM. L equals max 0, 1y CDOTF x. This loss encourages correct classification with a margin. Applications include text classification, image classification, spam detection, loss function workflow. A typical machine learning workflow with loss functions looks like this: training data, down pointing arrow, model prediction, down pointing arrow, loss function measures error, down pointing arrow, gradient descent updates weights, down pointing arrow, improved prediction. This loop repeats many times during training. Real-world applications. Loss functions are used in many AI systems. Computer vision, image classification and object detection, natural language processing, language translation and chatbots, finance, fraud detection and risk prediction, healthcare, medical diagnosis from imaging data, recommendation systems, product and movie recommendations. Advantages of loss functions. Loss functions provide several benefits. Advantages include measure prediction accuracy, guide model learning, allow optimization algorithms to work, improve model performance. Example concept: prediction error means loss means model improvement. Limitations and challenges. Choosing the wrong loss function can affect model performance. Challenges include sensitivity to outliers, difficulty selecting the right loss function. Different tasks require different losses. Example concept: wrong loss function means poor model training. Concepts learned from loss functions. Understanding loss functions helps learners understand. Checkmark how machine learning models measure prediction error. Checkmark how neural networks improve during training. Checkmark how optimization algorithms work. Checkmark how regression and classification models differ. Checkmark how AI systems learn from mistakes. Loss functions are essential for training machine learning and deep learning models. Simple definition: loss function, a mathematical function that measures the difference between a model's predicted value and the actual value. Final summary: loss functions play a critical role in machine learning and neural network training. They measure how incorrect a model's predictions are and guide the learning process. During training, models adjust their parameters to minimize the loss value, which leads to better predictions. Different loss functions such as MSE, MAE, cross-entropy, and hinge loss are used for different machine learning tasks. Understanding loss functions is essential for mastering machine learning, neural networks, and deep learning.